Hello and welcome. In today's video, I'm going to just be going over one of the really cool uses for the definite integral, which is how do we derive the formula for a circle? You may remember that I have previously stated in my calculus series, where I'm trying to go through all of calculus 1 through 3, that the idea of this definite integral is used for finding areas. Now, I just want to suppose is, how do we find the area for a circle? And let's imagine for a second we have no idea what the area of a circle is. So we're going to think here. If I draw a circle on the xy axis, and let's say for simplicity's sake, it has an origin of 0, 0. Well, the distance from the origin is always going to be the radius of said circle, r. So we know that this is going to intersect the x-axis at the point r and negative r. Okay. Now what we have to really think about here is, what is the equation for the circle? Well, it's going to be y squared plus x squared is equal to r squared. Well, we can't take an integral of this function. So what we're going to do is we're going to divide this function up. We're going to say that this is going to be y is equal to plus or minus the square root of r squared minus x squared. Well, let's real quickly just draw out what this function looks like. Well, we still have the same... I don't know if this is going to. Yeah, no, it's not going to. Alright, so in this bottom quadrant here, we have the function y is equal to negative square root of r squared minus x squared. But in this top part of the function, we have y is equal to the square root of r squared minus x squared. Well, just thinking for a moment, because if I were to integrate both of these and then add them together, it would be 0. I want to get the area for the circle that way. So what we're going to do is we're going to actually think of this as just the top portion. This y is equal to the square root of r squared minus x squared. So how can I find the total area if I'm only taking regard to this top function? Well, we know that this area up top is going to be half the area of the circle, so we can multiply it by 2. So we're going to just real quickly define a new function here. Let's call this z of x is equal to 2 times by the square root of r squared minus x squared. Now what I want to do with this function is I want to integrate this, as this is going to be the equation of, well, this really doesn't represent anything on the circle, but if I integrate this, this will give me the area under the curve. So we are going to get the integral, and remember that we're taking from negative r to r, as those are our bounds here, and that's where the radius will stop. Anything outside of that, the function is undefined, of 2 times by the square root of r squared minus x squared times by dx. Well, we're going to just pull this 2 out, so we're going to get 2, and I'm going to just remove this indefinite integral part for right now, or the definite integral part, and just make this into a definite integral from negative r, of the square root of r squared minus x squared dx. And once I evaluate this, I'm going to punch in the negative r and the r again. So, recall for a moment that we have several trig identities we can use to solve this, as this is in a form that's really not that integratable. So we're going to call x r times by sine theta. we're going to say our dx is going to be our cosine theta d theta. So now what we have to do is sub in our dx and our r times by sine of x. So we're now going to get this 2 times by the integral of the square root of r squared minus r squared sine squared of theta times by r cosine of theta d theta. Well, this is going to become 2 times by the integral of, we're going to factor an r squared, so this is going to become 1 minus sine squared. And using our Pythagorean identity, we know that's the same thing as r squared times by cosine squared. So we get the square root of r squared times by cosine squared times by r cosine of theta, cosine of theta d theta. All we have to do is simplify, so we get the integral of r times by cosine of theta squared, and that would be an r squared d theta. Okay, now we have to actually get to the harder parts here. So what we're going to do is I'm going to move everything around real quickly. So r in this case is just some constant, but we need to find what is cosine squared equal to. Now, if you know your trig identities, you know cosine squared of theta is going to be 1/2 plus 1/2 cosine of 2 theta. So we're going to sub in this identity here to make this function integratable. So we get 2 times by the integral of, and I'm actually just going to, of r squared times by 1/2 plus 1/2 cosine of 2 theta d theta. So now what we have to do is I'm actually just going to distribute this 2 inside of here. So I'm going to get, and I'm just going to distribute everything out. And I don't know why I put parentheses around the d theta. It should be there. There we go. So we get r squared, the integral of r squared, as that's going to be 2 times by r squared times by 1/2 plus r squared cosine of 2 theta d theta. Now integrating this, we get r squared times by theta plus r squared, plus r squared divided by 2 sine of 2 theta plus c. Well, I'm really not going to worry about this plus c, as this is supposed to be a definite integral. Now we have to solve for our original bounds in terms of theta. So I'm going to move this up, and I'm going to swap my color over to blue. We know that r is going to be equal to r sine theta. So we have to solve for sine theta in this case, or theta. So we get 1 is equal to sine of theta. Or theta is going to be equal to, well, sine is equal to 1 at pi over 2. Then solving for whenever, for the lower bound, negative r, we're going to get negative r is equal to r sine theta. So we're going to get sine theta is equal to negative 1. So theta must be equal to negative pi over 2. So we're evaluating this from pi over 2 to negative pi over 2. So we're going to plug in these values. So we get r squared times by pi over 2 plus r squared divided by 2 times by sine of 2 pi over 2 is just going to be 0, so that's easy. It nice and drops out. Minus, though, r squared, which in this case is going to be r squared still, times by our theta, which is negative pi divided by 2, plus r squared divided by 2. However, sine of negative pi over 2 times by 2, that's just sine of negative pi, which evaluates to 0. So what I'm really going to get here is we're going to get r squared times by pi over 2 minus r squared times by negative pi over 2. This negative and this negative are going to make positives. So we get r squared, and then the 2 pi's are just going to become pi, or pi times by r squared, for the formula of a circle. I hope you've enjoyed, and maybe this has helped you in some way. I don't know if it's helped me at all.